Okay, now that we have the protocol down for dimensional analysis, we kind of have the steps necessary to be able to be successful with that. What I want to do is take a look at some problems today that are going to be a little bit more relevant to what we're going to actually do in chemistry. So let's go ahead and start with this problem here. It says 62.43 grams of carbon atoms represent how many moles of carbon atoms? How many moles of carbon atoms? How do we approach this problem? Well, the first thing we're going to want to do is we're going to circle any numbers that we see. So 62.43, that's the number of carbon atoms that we're talking about. And we want to know how many moles does that represent. So the first thing we want to do is take the number that we've circled and we're going to put that over 1. So we have 62.43 grams of carbon divided by 1. That one holds a place for us. Whatever unit is in the upper left-hand corner is going to go in the lower right-hand corner, and whatever unit I want goes on the upper right-hand corner. All right? So I'm looking for moles of carbon. That's what goes right there. Now I'm going to take a look at cancellation. Grams of carbon cancel with grams of carbon. That's not by accident. That's by design. What are the numbers that go here? Where do I find out the number of grams that one mole of carbon weighs? Well, I do that from a periodic table. So in the periodic table, what I do simply is to look for carbon, and here it is right here, and the number in the lower part of the box, 12.01, will go to two numbers to the right of the decimal, will tell me how many grams that 1 mole of carbon weighs. So if I had 1 mole of carbon atoms in my hand, if I were holding 1 mole of carbon atoms in my hand, it would weigh 12.01 grams. Do I multiply or do I divide? I'm going to divide because 12.01 is on bottom. So 62.43 divided by 12.01, the number that I get is 5.19816. That's what appears on my calculator. And so what I'm going to do now is deal with significant digits. I have 4 here. This is unlimited. This is unlimited. That's 1.000 forever and ever and ever. So unlimited number of significant digits for the 1 mole. And I have 4 here. So between those two, 4 is the 4 here and 4 here, I need 4 numbers in my answer. So I'll underline the first 4 numbers here, 5.198. And the 1 does not put, it has to be 5 or bigger to push this 8 to a 9. So my final answer is 5.198 moles of carbon atoms, and I'm done. I've determined the number of carbon atoms, or the number of moles of carbon atoms in 62.43 grams of carbon atoms, okay? All right, let's take a look at the second problem. In this problem, what we've got is 13.20 moles of nitrogen atoms, and they want to know how many grams that weighs. So I'm going to circle what I know. 13.20 moles of nitrogen atoms weighs how many grams? I'm looking for mass. So what I'm going to do is take what I know, 13.20, and divide by 1. So 13.20, don't take that 0 off, it's significant. 13.20 moles of nitrogen divided by 1. Whatever unit's there is going to go right there. Just the unit, not the number. Moles here, moles of nitrogen here, moles of nitrogen there, and whatever I'm looking for goes right there. In this case, it's grams of nitrogen. Can I determine the number of grams of nitrogen that one mole of nitrogen weighs? Yes, I can. I need the periodic table. That's going to tell me how many grams that 1 mole weighs. For nitrogen, it is 14.01 grams. Recall for carbon it was 12.01. Nitrogen, for 1 mole of nitrogen, is a little heavier, 14.01 grams. So I put that number right there. The next thing I'm going to do is cancel. Moles of nitrogen, moles of nitrogen. That's not by accident, that's by design. I put moles of nitrogen there to cancel with moles of nitrogen here. And that's what I want, grams of nitrogen. Do I multiply or do I divide? I multiply because both are on the top. And when I do, on my calculator, I get 184.932. Those are the numbers that appear on my calculator screen. But I can only have, let's see, there's 1, 2, 3. That 0 is significant. Trailing zeros count if they're after a decimal. And trapped zeros count. That 0 counts as well. So I have 4 significant digits here, 4 significant digits here. I'll take 4 significant digits. The first 4 are 184.9. So 184.9 grams of nitrogen is my final answer. 184.9 grams of nitrogen, my final answer. All right. Okay, number 3. Number 3 says 62.43 grams of carbon atoms represents how many carbon atoms? So I want to know not how many moles, but how many actual carbon atoms that represents. So let's take a look. The first thing I'm going to do is circle any numbers that I see, and I have 62.43 grams of carbon atoms, and I want to know how many. Now, how many moles, but how many actual carbon atoms those are. So the first thing I'm going to do is I'm going to take what I know and put it over 1. 62.43 grams of carbon over 1. That 1 holds the place. Times whatever unit I want, or excuse me, whatever unit is here goes here. So if there's grams of carbon here, grams of carbon goes right there. So grams of carbon here, grams of carbon right there. And whatever unit I want goes on top. Now here's what you should know. I cannot go directly from grams of carbon to atoms of carbon, to the number of carbon atoms. I have to go through a mole intermediary. So how do I determine the number of grams that 1 mole weighs? Well, we've looked at the periodic table before. For carbon, it was 12.01 grams of carbon weighs 1 mole. So let me go through that again. Originally, I had been asked how many carbon atoms. The problem is I can't go directly from grams of carbon to the number of carbon atoms, so I have to go through a mole intermediary. I do know the number of grams that 1 mole of carbon weighs. It's 12.01. I saw that on the last problem, or the previous problem before that, how many grams 1 mole of carbon weighs. So I'm going to cancel grams of carbon with grams of carbon. And I'm going to ask myself, is that what I'm looking for? Am I looking for moles of carbon atoms? No. So the remedy, if I say no, is to keep going. Keep going. Whatever unit's there, whatever unit is there, is going to go right here. So if I have mole of carbon atoms here, I'm going to put mole of carbon atoms here. And whatever unit I want is going to go right there. I want to know atoms of carbon, the actual number of atoms of carbon. How many carbon atoms are there in 1 mole of carbon atoms? Well, there's Avogadro's number. It's a special number that is defined by 1 mole. In the same way that there are 2 things in a pair or 3 things in a triplet, there are 6.02 times 10 to the 23rd things, anything, whether it be atoms or elephants or ping pong balls or tennis rackets, it doesn't matter. There are 6.02 times 10 to the 23rd things in a mole of things. So there's 6.02 times 10 to the 23rd atoms in a mole of atoms, okay? So that's the relationship. Now moles will cancel with moles, and I'm left with atoms of carbon. I'm going to ask myself at this point, am I done? Is that what I'm looking for? How many yes, that's what I'm looking for. So I'll quit. What I'll do is I'll get my calculator at this point and start working. Now, some students will sometimes ask me, do I multiply the 62.43? They know not to multiply the 1 because it's just a waste of time. 62.43 times 6.02 times 10 to the 23rd and then divide by 12.01? Or do I say 62.43 divided by 12.01, get an answer, and then multiply by 6.02 times 10 to the 23rd? The answer is it doesn't really matter, okay? It doesn't make any difference however you do it, as long as you're multiplying the numbers on top and dividing by the numbers on bottom. I will caution you, though, on your calculator to make certain that you hit the equal button after the first operation. Let me give you an example of what I mean. Let's just say, for example, I'm not sure how much of this you can see, but you're going to multiply 62.43, okay, time, I'll tell you what, I'll do divide. I'll do the divide by 12.01, so divided by 12.01. At this point, don't hit multiplication, hit equal, get an answer. You don't even need to look at it, just get an answer by hitting equal, or enter I should say. And then you're going to multiply by times 6.02. Now I'm using a TI-84 plus. That means that the EE button is a secondary function, so I'll hit second EE. On your calculator, EE may not be a secondary function, but on mine it is. So second EE 23, and then I'll get my final answer, and I get this number, 3.129725 times 10 to the 24th. I can't keep all those numbers. How many can I keep? I have 4 significant digits here, 4 there, 3 there. Unfortunately, I can only keep 3 significant digits, so I'll take these right here. 3.12. The 9 is 5 or bigger, so that kicks this 2 up. So I get 3.1, not 2, 3.13 times 10 to the 24th carbon atoms. Check one more time to make sure that's what I'm looking for. How many carbon atoms? Yes, that's how many I'm looking for. That's what I'm looking for. 3.13 times 10 to the 24th atoms of carbon, and I'm done. All right, I'm finished. All right, let's take a look at number 4. Number 4 says 6.82 times 10 to the 31st atoms of boron represent how many moles of boron? So let's take a look at what I've got. Remember, look for numbers. That's what I'm looking for. 6.82 times 10 to the 34th atoms, and then what am I being asked for? Represent how many moles? Underline moles. Moles of boron. Take what I've circled, put it over 1. 6.82 times 10 to the 34th boron atoms, put that over 1. Times whatever unit is there, times, make the division sign first. Whatever unit's there goes right there, and whatever unit I want goes right there. I'm looking for moles of boron. Folks, notice how much of the problem I'm able to do without even really thinking. I'm just copying things down. Circling and copying. Circle this, underline that, copy from there to there, put it over 1 times whatever unit's there goes there. So very little thinking involved, and I'm very close to finishing this problem without even thinking about what I'm doing. How many boron atoms are there in 1 mole? There are not, don't make this mistake, there are not 6.02 times 10 to the 23rd moles in 1 atom. There's 6.02 times 10 to the 23rd boron atoms in 1 mole. Don't forget that number, by the way. 6.02 times 10 to the 23rd boron atoms in 1 mole. Is that what I'm looking for? Am I looking for moles of boron? Indeed I am, moles of boron. So I'm going to cancel this with this, and I'm left with moles of boron. Now, do I multiply or do I divide? This number is on top, this number is on top, this number is on the bottom. I'll divide. Let me go through that operation with you on the calculator. It's very important that you know on your calculator, the calculator that you will be using, that you know how to enter exponents. I'm using, again, a TI-84 plus. That means my EE button is secondary, okay? So we get 6.82 second EE, 31. Divided by 6.02 second EE, 23, and I get this number, 1.132890 times 10 to the 8th, times 10 to the 8th. I can't keep all of those. I have 3 significant digits here. I have 3 significant digits here. I can only have 3 significant digits here. 1.13 times 10 to the 8th moles of boron is my final answer. That's what was left here, moles of boron. Moles of boron is my final answer. And I'm done, okay? I'm finished. All right, let's go to number 5. Number 5 says, what is the mass of 5.42 times 10 to the 54th atoms of boron? What is the mass of 5.42 times 10 to the 54th atoms of boron? 5.42 times 10 to the 54th is what I know. I'm looking for mass. This is almost getting routine. We get 5.42 times 10 to the 54th boron atoms over 1 times whatever unit goes there, goes there. Boron atoms there, whatever I'm looking for goes there. Unfortunately, I cannot go from the number of boron atoms to the mass. So I have to go through moles. So when in doubt, go through moles, right? When in doubt, go through moles. It's going to require an extra step, but that's okay. Boron atoms and boron atoms is going to cancel. I'm going to ask myself, how many atoms are there in 1 mole? 6.02 times 10 to the 23rd boron atoms in 1 mole. Any kind of atoms in 1 mole, okay? 6.02 times 10 to the 23rd is the number of atoms in a mole of any element. I'll ask myself, is that what I'm looking for? Am I looking for moles of boron? No, I'm not. I'm going to require another step. Times, make a division sign, whatever unit is there is going to go right there. So boron, moles of boron there, moles of boron there, okay? Now what I'm going to do is I'm going to ask myself the question, what am I looking for? Grams of boron. What's the mass? I'm looking for grams of boron. How do I determine the number of grams of boron in 1 mole? I'm going to need the periodic table. So let me go to the periodic table and find boron. Boron is right here. Boron is element number 5, 10.81 grams per mole. 10.81 grams of boron in every mole. So I'll put that number right there. Now I'll ask myself, am I done? Am I looking for grams of boron? Yes, I am. So I'm done. Get the calculator out. I'm going to multiply 5.42 times 10 to the 54th by 10.81, hit the equal sign, then divide by 6.02 times 10 to the 23rd. You may ask, couldn't I have done this division first and then multiplied by? Yes, you could have if you would wanted to do that. Just make sure you hit that equal sign. By the way, some of you I know use the little caret sign on the calculator. If you do that, be aware that that you could easily make a mistake using that little sign there. If you do it, that's fine. Just make sure that you're getting the correct answer in practice problems so that you don't continue to make errors again and again and again. The answer that I get is 9.73259 times 10 to the 31st. All right? I can't keep all those significant digits. I've got 3 here, I've got 3 here, I've got 4 here. I'll take 3. The first 3 are 9.73. The 2 does not kick this 3 up, so it's 9.73 times 10 to the 31st. What's the unit? Grams of boron, and I'm done. That's my final answer. That is my solution. Okay, that's number 5. Let's take a look at number 6. Number 6 says, what is the mass of 6.48? What is the mass of 6.48 times 10 to the 26th molecules of methane? So for the first time, we're looking at molecules and not atoms. That's okay. Circle what you know. 6.48 molecules of methane, which is CH4, and we want to know what is the mass, right? So what we're going to do first is we're going to write down what we know. So in this case, we have 6.48 times 10 to the 26 molecules of CH4. Put that over 1. Put that over 1. Then times whatever unit is there, molecules of CH4 is going to go right there. And whatever unit I want goes right here. Now, unfortunately, I'm looking for mass, and I can't go directly from a molecule to a mass. I don't know the number of, I don't know the mass in grams of a molecule. So I'm going to have to go through a mole intermediate. Remember, when in doubt, go through moles. So I'm going to cancel molecules of CH4 with molecules of CH4 here, and I'm left with moles of CH4 molecules. How many molecules of CH4 are there in 1 mole? Well, how many things are there in a mole? There's 6.02 times 10 to the 23rd of anything in 1 mole, including molecules or atoms or whatever you want to make it. So 6.02 times 10 to the 23rd molecules in 1 mole of CH4. Now what I'm going to do is I'm going to ask myself, is that what I'm looking for? Am I interested in moles of CH4? No, I'm interested in the mass, so I have to keep going. Don't get your calculator out just yet. Keep going. Multiplied by times. Now make another division sign, and whatever unit is here is going to go right there. And whatever unit I want is going to go right there. I'm looking for grams. Can I determine the number of grams that 1 mole of CH4 molecules weighs? Yes, I can. How do I do it? Here's how I do it. Carbon has a mass from the periodic table of 12.01. Check me on that. And hydrogen has a mass of 1.01, but there's 4 of them, so the total mass for those 4 are 4.04. When I add those numbers up, I get 16.05. So 1 mole of CH4 molecules weighs 16.05 grams. Okay? Is this the unit that I'm looking for? Yes, I'm looking for mass in grams. I'm done. Cancel that unit with that number. By the way, don't cancel the number, just cancel the unit. All right, how do I handle this on the calculator? 6.48 second EE 26 times 16.05, hit the equal button. Divided by 6.02 second EE 23. If you're using a TI 84 Plus model, it's a secondary function, so hit the secondary button to get to the secondary function. Divided by 6.02 times 10 to the 23rd, and you get this number, 1.727641 times 10 to the 4th. Far too many numbers for us to hang on to. I have 3 significant digits here, 3 here, 4 here. I'll take 3. The first 3 are 1.72. The 7 is bigger than a 5. It's 5 or bigger, so it kicks this 2 up. I get 1.73 times 10 to the 4th grams of methane. That is my final answer. That's number 6. Let's go to number 7. Number 7 says this. Number 7 says, what is the volume of 8.42 moles of ammonia gas at STP? It appears to be because of the STP, it appears to be a difficult problem. It's very, very easy, as long as you remember one thing. Standard temperature and pressure simply means 0 degrees Celsius, 1 atmosphere pressure, but it also means this. Every gas, regardless of what the gas is, whether it's ammonia or any other gas, has the same volume at STP, and that's 22.4 liters. How is that going to help us in this problem? Circle what you know. It says we have 8.42 moles of ammonia gas. I want to know what is the volume. I just told you that every 1 mole of any gas at STP has a volume of 22.4 liters. So how are we going to use that? Take what you know, put it over 1. Whatever unit is there, goes there. Whatever unit you want goes right there. Liters of NH3. Do I know how many liters 1 mole weigh? How many liters 1 mole occupies? Well, I do at STP. It's 22.4 liters, regardless of the gas. So certainly this is ammonia. It's a gas, and so 22.4 liters of ammonia is the equivalent of 1 mole. Is that what I'm looking for? I'm looking for volume, so liters is the correct unit. So moles and moles go away, and I'm left with liters. 8.42 times 22.4, because they're both on top, I get this number. 1.88608 times 10 squared. I can only take three significant digits. I'll underline the first 3, 1.88. The 6 will kick the last 8 up to 9. 1.89 times 10 squared liters of ammonia is my final answer. 1.89 times 10 squared liters of ammonia. That's my final answer. Our final problem. Here we go. This one's going to be a little bit longer, so hang on. It says, how many hydrogen atoms are there in 1.06 grams of ammonia molecules? Okay, now don't panic. Okay, we can handle this. We've been working up to this problem. So the first thing we're going to do is circle any numbers. 1.0 grams of ammonia. How many hydrogen atoms? So we're dealing with 2 different substances here, ammonia and hydrogen. That's the first time we've done this. But we're going to stick with our basic protocol and, again, not panic. 1.06 grams of ammonia, put that number over 1. I may not even know how to do this problem yet, but at least I'm using my pen to guide my brain. 1.06 grams of ammonia over 1, and then multiply by whatever unit is here, goes there, and whatever unit I want is going to go right there. Now, I can't go directly from grams of ammonia to hydrogen atoms, number of hydrogen atoms, so I have to go through what? A mole intermediate. So I do know how many grams 1 mole of ammonia weighs. It's 17.04 grams. How did I get that number? What I did was I added the atomic mass for nitrogen. I added that to 3 hydrogens, which were 1.01 apiece. So nitrogen was 14.01. Hydrogen is 1.01, but I multiplied that by 3 for a total of 17.04, okay? So I know the molar mass now for ammonia. I'm going to cancel this with this. I know that moles of ammonia is not what I want, but I'm going to get an answer right now. I'm just going to get an intermediate answer right now. When I take this number and divide by this, I get 6.22 times 10 squared moles of ammonia. Times 10 squared moles of ammonia. I'm going to take that number, 6.22 times 10 squared moles of ammonia, over 1, times whatever unit is here is going to go there, and whatever unit I want is going to go here. Now I need to make a special. I have to go from units of ammonia to units of hydrogen. How many moles of hydrogen are contained in 1 mole of ammonia? Now this is a conceptual problem right here. If I were to ask you how many headlights does an automobile have, you would say 2. And then if I were to ask you if you had a mole of automobiles, how many moles of headlights would you have, and you would say 2. If I say how many tires do you have, if you have 1 mole of cars, how many tires would you have? You would say 4 moles, because since one car has 4 moles. In the same way, for NH3, if you have 1 mole of NH3, you have 3 moles of hydrogen atoms, because there's 3 hydrogens in 1 ammonia molecule. So that's the conceptual hurdle that we have to jump over now. We've got this number of moles of NH3, we'll cancel moles with moles, and now we're left with moles of hydrogen atoms. Not quite where we need to be, but certainly closer, because we're now dealing with hydrogen atoms. We'll take 6.22 times 10 to the minus 2 times 3, and we get 1.87 times 10 to the minus 1 moles of hydrogen atoms. Moles of hydrogen atoms, okay? All right, let's take that 1.87 times 10 to the minus 1 moles of hydrogen atoms, and let's multiply that by, put that over 1, and multiply that by, whatever unit is here is going to go right there. Whatever unit is here is going to go right there. And so, I'll ask myself the question, how many hydrogen atoms are there in 1 mole of hydrogen atoms? Here comes our old friend Avogadro again, 6.02 times 10 to the 23rd hydrogen atoms in 1 mole. So moles of hydrogen atoms and moles of hydrogen atoms cancel, and I'm left with this number. When I multiply these two in my calculator, I get 1.12574 times 10 to the 23rd hydrogen atoms. Almost done. 3 significant digits here, 3 significant digits here. I can only have 3. The 5 is 5 or bigger. We'll kick that 2 up, and I'm left with 1.13 times 10 to the 23rd hydrogen atoms. That's my final answer. Okay, folks, that takes us through dimensional analysis. You should be more than ready now to handle stoichiometric calculations. If you need more help, go ahead and review these video podcasts again, and I'll see you on the next one. Thank you. Bye-bye.